Is artificial intelligence just another overhyped tech bubble? Or is it truly the game changer everyone's been talking about? If you're caught between AI skepticism and unbridled enthusiasm, you're not alone. The truth is, we're riding the roller coaster of technological evolution, as described by the Gartner hype cycle. Welcome to Navigating the AI Revolution Beyond the Hype. I'm Richard Walker from Lucidate, and today we're going to demystify the journey of AI, particularly generative AI, and give you the information you need to decide on whether your project's needs are best met with GenAI or whether they will be better served with another technology. Here's the thing, every transformative technology from the internet to blockchain has followed this hype cycle. Initial excitement, inflated expectations, disillusionment, and finally, productive implementation. GenAI is no different, but here's where it gets interesting and where you can gain a crucial advantage. The firms that will dominate in the AI era aren't those blindly throwing generative AI at every problem. No, the winners are those who master the art of matching the right AI technique to the right application. It's not about having the shiniest new AI toy. It's about having the right tool for the job. By the end of this video, you'll have a clear roadmap for navigating the AI landscape. You'll know when to leverage the power of generative AI and when to look at other technology techniques. And most importantly, how to identify the perfect use case for each application in your business. We're not just going to talk about avoiding pitfalls, we're going to show you how to turn an understanding of what tool to use for what use case into your secret weapon for AI success. In capital markets and other industries, there are several areas where careful consideration and selection of the right tools adds value and saves otherwise wasted resources. Let's look at the landscape of use cases and technology tools and then match them up with which technology is suited for each application. In a world where everyone is claiming that their system is powered by AI, we'll see that oftentimes AI or GenAI is not the most effective way to attack and solve a problem. Other tools and approaches offer way better outcomes. In a Towards AI post by Christopher Tao, inspired by a Gartner conference in the summer of 2024, Christopher identifies 12 common use cases or application constellations that use AI. These include prediction and forecasting. This technique uses historical data and trends to estimate future outcomes. In capital markets, it's applied in fixed income research, helping analysts predict bond yields and interest rate movements. Outside of finance, it's crucial for supply chain demand forecasting, enabling businesses to optimize inventory levels and reduce waste. The planning constellation focuses on designing strategies and allocating resources effectively. Capital markets utilize this for optimal trade execution scheduling, minimizing market impact and transaction costs. Manufacturers leverage planning AI to optimize production processes, reducing downtime and maximizing output. Decision intelligence analyzes data to provide actionable insights. In finance, a great use case is algorithmic trading by processing vast amounts of market data to make split-second trading decisions. Hospitals use decision intelligence for resource allocation, ensuring optimal distribution of staff, equipment, and beds. Moving on to autonomous systems, which operate without human intervention. In finance, we see this in automated portfolio rebalancing, where AI adjusts investment allocations based on market conditions. In transportation, self-driving vehicles showcase how autonomous systems can revolutionize travel and delivery services. Classification techniques divide data into segments based on specific attributes. In finance, this automates credit rating classification, streamlining loan approval processes. Other industries use it for customer churn prediction, identifying at-risk customers for targeted retention efforts. Recommender systems suggest options based on user behavior and preferences. They can personalize investment product recommendations in capital markets, matching investors with suitable financial instruments. In e-commerce, these recommender systems drive product suggestions, enhancing customer experience and boosting sales. Perception AI interprets sensory data like images, sound, or text. In finance, it's able to gauge real-time news sentiment, gauging market mood from countless news sources. In healthcare, medical imaging benefits from AI's ability to analyze X-rays or MRIs. Intelligent automation enhances traditional automation processes to be more adaptive. In capital markets, it can be used to aid capital allocation, dynamically adjusting allocation based on risk-adjusted returns. Smart home energy management systems showcase how this technology optimizes resource usage in everyday life. Anomaly detection identifies data points that deviate from expected behavior. It's crucial in spotting market manipulation in finance, flagging suspicious trading patterns, fraud, or money laundering. In cybersecurity, it detects threats by identifying unusual network activity or user behavior. Content generation creates new text or images based on learned patterns. In capital markets, it can summarize company earnings reports, distilling key information for investors. Marketing teams can use it to create personalized email campaigns, tailoring messages to individual customer preferences. Conversational user interfaces enable natural language interaction between humans and digital systems. In finance, AI-powered text to SQL report generation allows non-technical users to query databases using plain language. Customer service virtual assistants across industries demonstrate how this technology can enhance end-user support. Finally, knowledge discovery identifies patterns, insights, and relationships within large datasets. In finance, it can uncover hidden market correlations, revealing non-obvious connections between different asset classes or economic factors. The pharmaceutical industry uses it for drug discovery, analyzing vast chemical databases to identify potential new treatments. As you can see, AI techniques form a diverse ecosystem of applications, each constellation offering unique benefits across different sectors. The key is matching the right technique to the right use case for maximum impact. By understanding these categories and their applications, businesses can make informed decisions about implementing AI to drive innovation and efficiency. Now that we've explored the diverse landscape of AI use cases, let's dive into the 6 key technology solutions that can address these applications. Again, I've used the classifications identified by Christopher Tao in his Towards AI article. Each of these techniques has its own strengths and weaknesses, making each technique more or less suitable for different scenarios. Graphs. Powerful tools for representing and analyzing complex relationships and workflows. They excel in scenarios where interconnections are crucial. Their strengths, well, they're ideal for visualizing and processing network-like structures. Their weaknesses, well, they can become computationally expensive for very large data sets. They're best suited for things like interbank lending networks, modeling the interconnections between financial institutions to assess systemic risk and the potential for contagion effects in the case of bank failures. Graphs are less suitable for tasks like content generation or anomaly detection. Rules and heuristics. This approach uses predefined rules based on expert knowledge or established practices. Their strengths, well, they're transparent, they're easy to interpret and quick to implement. Their weaknesses, they lack flexibility and the ability to learn from new data. They're best suited for workflow systems such as trade data enrichment with clear predefined criteria. Rules and heuristics are less effective for tasks requiring nuanced understanding or adaptation, like perception or autonomous systems. Simulation creates models to answer what-if questions and explore potential scenarios. Strengths, they're excellent for scenario planning and risk assessment. Their weaknesses, they can be very computationally intensive and rely heavily on the accuracy of the underlying model. They're best suited for financial modeling, such as assessing the impact of interest rate changes on bank profitability. They're less suitable for real-time decision-making or content generation tasks. Optimization. This technique finds the best parameters for a given formula or equation to maximize or minimize specific outcomes. Strengths. They're highly effective for problems with clear objectives and constraints. Weaknesses. They can be sensitive to initial conditions and may find local rather than global optima. They're best suited for portfolio optimization in finance, balancing risk and return. It's less applicable to tasks like perception or natural language processing. Machine learning. This uber broad category includes various techniques like linear regression, support vector machines, clustering, and decision trees. Strengths. They're capable of finding patterns in large data sets and making predictions. Weaknesses. They require very large amounts of very high quality data and can be computationally intensive. They're best suited for predictive tasks from large, complex data sets, such as credit risk assessment. They're less suitable for tasks requiring explicit reasoning or creativity. Finally, generative AI models. This includes large language models and other generative techniques. Strengths. They're excellent at generating human-like text and understanding context. The weaknesses. They can be unpredictable. They may hallucinate, and they require significant computational resources, particularly to train. They're best suited for content generation tasks like creating earnings report summaries or natural language reporting interfaces. They're less suitable for precise numerical calculations or rule-based decision-making. Understanding these technologies and their appropriate applications is crucial for successful AI implementation. For example, while generative AI is excellent for creating summaries of earnings calls or natural language reporting interfaces, it would not be the best choice for detecting market manipulation or optimizing trade execution. Similarly, while machine learning excels at predicting customer churn or credit ratings, rules and heuristics might be more appropriate for implementing clear, auditable processes in regulatory compliance. By matching the right technology to the right use case, you can maximize the effectiveness of your AI initiatives and avoid the pitfalls of misapplied solutions. Remember, the goal isn't to use the most advanced or hyped technology, but to choose the one that best solves your specific business problem. As we move forward in the AI revolution, the winners will be those who can navigate this complex landscape, understanding when to leverage the power of cutting-edge generative models and when to rely on more traditional, proven techniques. By mastering this art of selection, you'll be well positioned to harness the true potential of AI in your organization.